Hello everyone. I don't see anybody has joined, so let's wait. Let's wait for 2 minutes. Hi Rohit. Hope you can hear me, right?
Yes, yes.
Yeah. Let's give it a start. Let others pour in. We're not able to do much yesterday, right? So let's try to do a bit more. Okay. I hope you can see my screen, right?
Yes, yes.
So let's start with the practical implementation. So just to do a quick review, yesterday we were looking at a special case when if we have the categorical variable. So how can we apply the regression analysis in that case is what our question was. I have not written down the notes. Let me just quickly write it here. So what we discussed is if we have a categorical variable with two distinct values, okay, and something that I missed to tell you yesterday, which is one of the properties as well, which I should also tell you here. If we have a categorical variable, or maybe I can write over here that overall there are two methods. Okay, two methods. One is label encoding, and the other is one hot encoding. Each has its own pros and cons, and according to the data or scenario, we would need to use at least one and sometimes both. Okay, for one or more, for one or more categorical columns or features in our data. Okay, sometimes, which we will see at a later stage, so maybe I'll not write this over here, I'll just say this for the record. Sometimes when we are doing cases like, is it going to rain tomorrow or not? So let's say I have some historical data with some weather details, and then my target column, my label is yes or no, yes or no. So on a certain day, so and so features were there in the environment. Was there a rain? The answer is yes. So in the target column, I have a value yes, right? So yes, no things are there, right? So I may want to convert that field as well into 0 and 1 using label encoding. So it's also applicable on the targets. So just that I have written over here that we convert only the features. That is not only the case. We convert the targets as well. Okay. Now, in our case, let's try to limit ourselves to regression. In our case, if we have a categorical variable, this is a small form, categorical variable. If we have a categorical variable with two distinct values, we usually go with uh, label encoding. I'll just write it like this, label encoding, because as we saw yesterday, in this case, we get two advantages, right? So let me just write the two advantages. The data becomes scaled, that is within a range of 0 and 1, right? The second thing is, this is something which I missed to tell you yesterday, we can also provide, or we are inherently providing an order, okay, to the two different or two distinct values in the field. Okay, what I mean by this is, let's say if I go back to the same example, whether it will rain or not, or maybe what we are going to practically do now is that we'll add a categorical field by doing some, let's say, a dummy and a very bogus kind of a calculation just to add a dummy field there. And then if, let's say, we are interested in small category of products, then we will mark it as 0. If we are not interested in small, I'm sorry, if we are not interested in small, we'll mark it as 0. And if we are interested in large, then we are going to mark it as 1. Or in other words, to represent the size of small, we have represented, or we have given it a label of 0. To represent large, we have given it a label of 1. Right? So that's also another very intuitive thing that label encoding provides. Out of the box, it gives you the ability to determine the size or the order, right? So you are basically converting a categorical variable with no inherent order, which was there earlier. Large and small may or may not have any order, right? But when you convert that into a numerical form, you are actually giving it an order. You're trying to impose some kind of order in there. So this helps at times because it's really intuitive for you to understand, for the modeler to understand, or for whomsoever is looking at the data to understand what is going on over here, which takes precedence over the other, right? So if you simply provide a data to any experienced person in this data field, and there is this one categorical field which says, was there rain yesterday? And the values are 0 and 1. Intuitively, that person says, okay, 1 means yes, 0 means no, right? So that kind of an effect is there. So that there comes an order, there comes a value. The third important advantage is it's simple to digest, right? It's very simple to digest. It's a very simple technique, right? Now, if we have more than two, okay, distinct values or classes, okay, this is a term which will come very, very handy later on, okay? Please don't ignore this term. This term is very, very important. If there are more than two distinct values or classes of values in a categorical variable, then we may want to use one hot encoding instead of label encoding, since using label encoding will no longer keep the range of values within limits, right? So this is what we saw yesterday. If I have 15 distinct values in one field, and if I give it a label encoding from 0 to 14, 0 being for the first item, 14 being for the 15th item, and I'm creating a range of values between 0 to 14, which may no longer relate to a normal distribution, or which may no longer relate to a limited or scaled data, right? So that's the first, you can say, the use case where we will use one hot encoding, or one of the disadvantages or limitations of label encoding, right? And the second thing is, then we may want to use one hot encoding in case of label encoding, because we can create p, okay, p number of columns where p is equal to the number of classes in our field, okay? So I can say in each column we will end up having a controlled range of values from 0 to 1, right? We will have a controlled range of values, right? But the disadvantages, now comes the disadvantage of one hot encoding. If we have large number of unique values or classes in a categorical variable, we end up having uh, I can't say multi-dimensionality problem, but I can say end up having lots and lots of columns. Okay, good news. I'll again put it over here. Good news. We have techniques. We have techniques to take care of this. This we will look at later on, but just to give you an intuition, we have techniques like principal component analysis, which we will do. which is going to help us reduce those number of columns, right? It will help us concentrate on 1, 2, or 3, usually 2 of the most important columns, which is going to add most of the variance in the data, but we'll look into it later, right? So as of now, this is what we have studied yesterday. Quick revision. Let's go back to code. So what we are trying to do, let's add a new categorical feature in the data. Okay, we will code this. Okay, so this is entirely dummy, sorry, dummy, and has no meaning. Okay, so this code is hence for illustration purposes. Okay, this will not solve our it's a modeling. It's not going to add any values. It's just an example, right? So before I do that, maybe what I can do, I can just come over here and I can say, what was the last section number? Give me 1 minute. 8, right? I believe 8 was the last one. So I'll just put 9 over here. So 9 effects of categorical variable on linear, no, on, I'll just say regression. Okay, so we are trying to look into this. So what I'm going to do now is that, let's say I want to, I've already imported NumPy or what. Let me just quickly check, because I need NumPy for this. Yes, I have. Good. So what I'm going to do, first of all, I'm going to generate or hold on to a random seed. Okay, don't worry about the code right now. You will come to know what I'm doing. So I'm going to set a seed. So how to set a seed in NumPy is this function, and I'm just going to enter any value over here. So 1, 2, 3, 4, 5. Okay. Why am I doing this is because if I don't do this later on, I'm going to use a random function, random.rand. Okay. Here I've used np.random.seed. I'm now going to use an np.random.rand to randomly generate the values, the values that I'm going to use in this new column. Okay, this new column will be called class, let's say, and I'm going to add some values in that column, and I don't have any predefined logic. I'm going to be as random as possible. So that I can maintain the reproducibility, I am setting a seed. If I don't set a seed, okay, and if I run the code and then I give this notebook to you, or if I run this code again and again and again, every time I run this notebook, in its entirety, it's going to generate a different set of randomness. I just want to keep the randomness strict or the same throughout the lifetime. So this is exactly what we did for training and test split, right? We use that random state kind of a variable, which we fixed with a value. The reason we fixed it with a value is because we don't want to change the individual samples which are taken in the training set and the testing set, right? So the same thing we are doing over here. Now let's try to let's say um, uh, create. I'll start with, let's say, booleans. Create a set of booleans. Okay, create a set of booleans for our new column. Okay, later we will convert this into a text. Okay, don't worry. So what I'm going to say, nums. Okay, any variable nums is equal to np dot random dot rand. This is when I'm going to generate that random number. I'm going to take the length of my data set. So I've just pressed tab. It's a bit slow today, my laptop. I don't know why. So that's a, yeah, so this is my data set. So what I'm doing is, if you look at nums, if I print nums over here and simply execute this thing, that it is simply generating a random number. Okay, it is generating a random number for how many times. If you take a length of this num, okay, if you take a length of this, then you will come to know that it is exactly 200. Why 200 I need? Because I need this length of random numbers array to be the same as the length of my advertising data set. Okay, don't worry, you will come to know what I am doing or why I'm trying to do this. Now what I'm going to do is that I'm going to create a Boolean variable. Okay, a Boolean variable, which is, I want to mask this variable nums, where, or the condition to this is, this value, let's say, is greater than 0.5. So if I now print mask nums, okay, what is going to happen is you will see a value true, false, true, false, true, false, true, false, right? So wherever the value of nums in my array or the value in the array nums is greater than 0.5, I've given it label true. And if it is not, I've given it label false. So as you can see clearly, I've created a 1D array. So it is just a series, just another column, right? I can simply take this and put it as a column in my data frame. Right, so this is how I've generated a random column, a very, very dummy and random, right? So what I'm going to do is now we will add this new column. So what I'm going to do now is advertising. I'm going to call the name of the column as scale. Okay, this is one way. I don't know whether we have covered this while doing our initial days of, let's say, pandas. In pandas data frame, you can add a new column in existing data frame only by doing this. So you write some expression over here. That expression evaluates to some value and assigns that value to this new variable or this new feature called a scale in this data frame that I have mentioned over here, which is advertising, right? So this is one very easy way to add a new column. Okay, so I'm going to first of all assign all the values as small. Okay, just randomly, I'm just going to assign all the values as small. Now I'm going to show you a trick. Advertising dot, there is a function. Okay, and I would request you, or I can share you all the materials relevant to pandas, which is going to make us even better in the data analysis using pandas. I can also share you some YouTube playlists. Maybe I'll put it into our LMS. So these kind of functions are really going to be useful when you're doing data wrangling or data processing, some of which we have covered, but many of them we are going to cover now. So what we are doing now is I'm using a function called lock. Okay, and I'm saying that I want to put the value mask, sorry, not mark, mask nums, okay, in the place of, okay, in place of the column scale, or as value of the column scale, okay, being equal to large. Okay, what I'm doing exactly over here is in mask nums, I have a 1D array. That 1D array is what? True, false, true, false, true, false, right? Wherever, okay, it is true, then in this column scale, you put the value large. Else you don't do it, right? Else you keep the value as small. Are you getting my point? So initially I have assigned all the values as small. Now I'm simply taking this as a location identifier. Okay, so I'm taking this array of booleans as a location identifier to impute value or to enter value or to update the value of this column called scale with this value large. So this is my expected value, which is large. Okay, so if I do this and then check the sample of the data frame, I'm going to say advertising dot head, and I will clearly see after execution it has given me the data which I need. I can even do it multiple number of times. It's not going to make any difference. Okay, it's really not going to make any difference because this code is so intuitive, right? I mean, the way Python helps us do this is that you can run this kind of code as many number of times, but this is not the case. Word of caution or a word of advice, this is not the case with everything when it comes to Jupyter Notebook. Okay, be very careful if you are doing any rerunning of the same code again and again and again. It might do wrong things to your data, right? So basis my experience, I'll share that, but you have to be very careful. So it's always good that because we have a code cell and an output cell, we should always look at the output more and more and try to see what is happening over there, what are the errors we are getting, and accordingly we choose to either put each and every sentence or each and every code like this into a different cell. That's the best idea, actually. That's really the best idea. One of my teachers who taught me how to do data wrangling, he actually used this technique always. He always uses a new cell to create a new code. So just like in this case, I have entered all the lines of code here. So we have what, 3, 4, 5, 6 lines of code, right? So 6 lines of code are put into the same cell to write the code. Ideal condition, what he would suggest here is that he would put everything in individual cells so that he can debug them individually, treat them individually, right? That's a very good practice. Only to save time, I'm not doing this. Okay. So I have added a new column called scale. Okay, this might be the scale of the sales that I'm doing, or might be the scale of the factory. Okay, let's try to define scale. I mean, it's not good that we are having a name, but we don't have a definition. So let's say this scale feature, the one that we have added, is the scale of the factory. Okay, how large or how small that factory is, where I'm actually producing the quantity, okay, of my item. Okay, so let's say when I invest in these three areas, so and so thousands of dollars, and I am having a factory where I can do large scale kind of a production, I can get a sales, or I get a sales of 22.1, right? So let's say even more pragmatic way to look into this will be, these factories are, let's say, rented, or the workshops or the warehouses are actually rented, so they're not mine. So one day I get a large factory, one day I get a small factory, and so on, right? So if I do this, then now I have a categorical variable. So this categorical variable has how many values? I know this. I know this because I've imputed it. But if in case you don't know, if in case you get a data set where you don't know what are the distinct values, what you do is that to check the distinct values in a categorical variable in Python, what we are going to do, advertising is the data frame, scale is the column name, dot value underscore counts, and then you do enter. It clearly gives you what is the distribution of the data. You have 108 values, which is large, 92 values, which is small. Okay, this is entirely random, right? Now I will take this, and as I can clearly see, there is a large and small kind of thing. So I can see basis my notes. I'll go back to my notes. Okay, my notes are saying if I have a categorical variable with two distinct values, I will usually go with label encoding, right? I'll go with label encoding. I can do a label encoding. Now there are multiple ways. I'll show you two ways. Okay, one way, let's perform manual label encoding. Okay, what do you mean by manual? I'm going to create the data structures manually, okay, by hand. I'm not going to use any function, any library which Python has already provided. I'm going to do this by my hand. Okay, I'm going to use a Python dictionary. I'm going to put the values, map them with the data, create a new column. That's it. The other way, again, I'll fall back to the libraries which are already created in Python. In this case, again, the infamous scikit-learn. In scikit-learn, there is a data processing module which already provides me with the facility to do label encoding, right? That I can directly call, and I can do the same thing again, fit and transform, right? Just like I imported the library earlier to do scaling, right? The standard scaler thing or the min-max scaler thing. In the same way, I imported the library, I call the fit transform function, and it does this for me. What is the difference? The difference is if I'm doing it manually, you can select the labels. If it is done by scikit-learn, it is entirely random. You can't control if large is 1 and small is 0. Okay, it's entirely dependent on how scikit-learn is going to read the data. In other words, how its code is going to act into the scenario which you have in hand. Okay, that is the difference. I've always informed you earlier, scikit-learn is a black box. It's not going to tell you how it is implemented. You may want to go to GitHub, look at the code of scikit-learn written in C, C++. If you have experience in that language, you will be able to understand what they're doing. Okay, you are more than free to do the research, but if you're able to find something, that's what you learn from it. Okay, but out of the box, as an user of the API, in the documentation, you will not find enough details to find out why it marks or labels a certain value in a categorical variable as one as the other one as equal to 0. Okay, so let's try to do this in a manual way. And what we are going to do is that let's try to create a new field. Okay, so we are going to create a new field. We'll create a new field called, I don't know, advertising, and I'm going to give this name is large. Okay, so is large is, let's say, a field which is going to contain two values. If it is large, the value is 1. If it is not large, the value is 0. So for large, the value will be 1. For small, the value will be 0. Simple. How do I do that? It's as simple as this. Advertising dot scale. Okay, this is one more way to call a column in a data frame if that column name does not have a space. So one way to call a column name is this. One way to select a column name is this, right? One way to select a column name is this. But if you look at this column, the scale column that we have added, we don't have any spaces. So instead of doing this, I can also do this. I can just do dot scale and it is going to call that. Okay. This is not a good way, by the way. This complicates your code. I would actually recommend you using this way. So I'm going to roll back. I'm going to roll back and I'm going to call it like this. Okay. Now on this, I want to use a function. Okay. We have already looked into some functions, if you remember, when we are going through the basics of Python. But I am not sure whether we have looked into this function, this specific data wrangling function, which is known as map. Okay. This is not limited to data wrangling. Map has a variety of different use cases, but it is most commonly used when it comes to data wrangling. Data wrangling is just a part of your data science life cycle that we are doing over here. We're trying to wrangle the data so that we can add fields or we can modify fields. We don't remove anything as part of the data wrangling. Wrangling is when, let's say, I have a text field and I have a lot of spaces. Right in the value, in each and every row I have some value. Let's say in each and every row I have the introduction given by the individual employees of my organization. When he or she joined the organization, they gave some speech and that speech is converted into text and it is there. I just want to remove all the spaces, right? So that's called wrangling. I'm not deleting any word, right? I'm not going to delete. I'm not going to delete the entries for me or for you. I just want to wrangle it. I just want to prepare it, right? So that's the area known as the data wrangling process. There will be a lot of data wrangling if you have an actual data set. Okay. Now, in this case, what we are using is a map function, and inside the map function, what I'm going to say in this bracket, I'm going to say use a dictionary-based mapping. If you find, okay, if you find in that advertising scale column, if you find a value which is small, okay, sorry, I'll it back, replace it with 0 or map it with 0. If you find a value which is large, map it with 1. This is the meaning of this function map. It maps the value small. If it finds small in this column, in any of the row, it's going to map it with 0. It finds large, it is going to map it with 1. Okay, that's it. If I now see what it is going to, again, a very bad practice. I should have created a new cell just to save time. I'm doing this. If I press enter, I get this. See what is happening in every large, there is a 1. For every small, there is a 0. Small is 0, large is 1. Small is 0, large is 1. It is done for the entire data set. Now, I don't need this categorical variable. Are you getting my point? So this is how I've manually performed label encoding on the scale field. Okay. On the scale field, I've performed manual label encoding. Anyone has any doubts until this time? Anyone? Any questions?
No questions from my side.
Okay, let's continue. Okay, so this is one way, right? This is one way of doing it. There is one more way. Let's quickly look at that way, and then we can look into the linear regression. Maybe let's try to fit the model and see how it goes. Okay, again, we are going to take the same thing. So let me just go back and take my code. Y2 print, right? I'll just take this. I'll take this and come over here. I'll say, now we will fit a model, okay? Model using TV, radio, and our new column, okay, is large, okay, to see the relationship, okay. So I'm pasting my code here. I'm going to change the names, okay. This is my multiple linear regression using stats model version 3. Stat model function is used. I'm doing ordinary least square. formula that I'm using is TV is a function of, or sales, I'm sorry, sales is a function of TV plus a radio plus is large. Okay, the data set is advertising. I want to fit this model using this assumption, and then I'm going to print the summary. Let's see what happens. This is the summary. Let's see what value we have added. First and foremost, our R square value, has it improved or no? It's quite good. It is near to 1, but has it improved? Let's quickly go back and see. What was our last model? Where was our last model? Here, you see, exactly same value, 903, 902. Okay, this is the advantage. The reason why I'm specifically showing this to you is, this is the advantage of two things that we have done over here. We have not done one thing, we have done two. We have done the label encoding, and because our column had only two unique values, it has scaled the data in the range 0 and 1, because we have manually chosen the labels, right? Because we have scaled the data does not affect R square or adjusted R square. Okay, this is the biggest advantage of scaling the data. Okay, this is the most important reason why we always scale the data, irrespective of increase or a degrade in the performance which we might find from our p value. We often do a mistake. We look at the p value and we say, okay, here I have e to the power minus 99. This is really very low. What about if I had something like e to the power minus 100 or e to the power minus 200? This would have been even a better value, a much lower p value. So in this case, in the other case, I would have got a better model. The answer is no. The model might be doing a mistake, and that mistake we will explain in great depth at a later stage, which is known as overfitting. It is trying to remember the patterns. It is trying to memorize the patterns in your training data. That's exactly not what you want it to do. Okay, that's why we must always scale in any practical sense, in any practical scenario. We must always scale our data, because it has no impact if we scale our data. Just like we did in this case, we added this new column which is label encoded. It is within a fixed range. It did not make any change to the R square value, right? It does not inflate it, or otherwise we know the more columns we add, the R square value will get increased. That's why we look at adjusted R square. We are penalizing R square, right? So that's the first learning. The second learning, we have a very good p value. So we have a good model. I don't know whether it's really usable or not. We'll see. But we have a very good model. Now let's try to figure out if this new column that we have added, is that adding any value? I don't think so. Why? Because if you look at this, TV has this coefficient and this p value, very, very close to 0. Radio has this coefficient. We have already found this earlier. It is exactly the same. And it has this p value. If you look at this intercept, right, it is also the same. You can go back and check the value if you want. So these three values are exactly the same as my previous multiple linear regression model using stats model library. What about this? This coefficient is negative. And the p-value, look at this p-value, it's 0.256. It's clearly, this variable does not help us to reject my null hypothesis. This is a really bad variable. I will not use this. I don't like this variable. Why? Because it does not have a good p-value. It's not adding much value to my model itself, right? It's not going to add too much of a value. But I can still use this combination to create that function which I created earlier to calculate the value of sales quantity. That I can do. That is plain simple mathematics that I can do. But from this output, I can clearly see these three is actually adding most of the value, because for this three, my p value is really good, right? But for this one, it is 0.256, much, much greater than 0.05, which is our significance level or alpha. Hence, we as a data scientist are not in a position to reject the null hypothesis. Hence, this new column is our enemy, right? Although we did not add any value, right? I understand this was a completely dummy use case, but I hope I was able to explain you how to do label encoding, right? Now, I'll quickly show you how to do label encoding using scikit-learn, and then we'll move ahead. Okay, for that we will add a new library over here. If I remember it correctly, it was sklearn dot pre-processing only import. We are doing label encoding. Label encoding. Let's run this and see if this really works or not. Else we will go to Google and find out. No, it doesn't run. Okay, it doesn't run. There is some problem. Let me find out. Okay, let's go to Google. sklearn label encoder. I think it was label encoder. But let's try to check quickly. Maybe I've done a spelling mistake. Yeah, it is pre-processing, but it is label encoder. It is not encoding. So that's the mistake that I've done. Okay, so this library used for label encoding categorical variables with 1 to 2 classes. Okay, so let's just run this. Done. I executed it. Let's go back. I'm going to now let's perform the label encoding using sklearn. So what I'm going to do, I'm going to add a new column and then I'm going to do. So first of all, I have to create a new object. This is how you create a new object. You always have to create a new object for label encoding or for any such case, because this is actually a class that you are calling. So you are calling the class label encoding, and you are creating a blank object, okay, of that class, and then we are going to fit the methods on top of that class. So what we are going to do over here, fit the data and get the output. Okay, so now we are simply going to use le.fit transform, and I'm going to pass advertising, and then I'm going to pass that value scale. If I do this and if I run this, okay, oh sorry, again I did the same mistake. Okay, if I go ahead and run this, what it is going to exactly do is it is going to fit and transform label encoding on this variable itself. On this variable only, it's going to make the transformation. It's going to replace it, right? But that's not what I want. I want a new column is large sk, okay, because I just want to remember or name this column as the one that I've got from scikit-learn. So sk is this. Okay, let's see if this code works, right? It has worked. Now let's check the data. Let's check the data. So I'm going to say advertising head 20. Sorry, not 2, head 20. Now see what it is doing. It has done exactly the opposite of what we have done. It has given 0 to large, okay, and 1 to small. Why do you think that is the case? We don't know. Maybe it has gone through this assumption that L comes first in the alphabetical order than S. So it has arranged the categorical variable in an alphabetical order. Large comes first, then comes small, right? Because L comes first, S comes later. So it's given 0 to large, 1 to small, right? So this is why you don't know what it is exactly going to do. This is exactly what I was talking about. You don't know what it is going to do to you, right? Because it's a black box. But then you can also use this and try to figure out what is happening. So if you would like to create another model, you can again use this. Let's do it for the sake of doing it. So I can create this fourth model, and here rather than is large, I'm going to use is large sk. Okay, I'm going to call this fourth one, and I'm going to see the summary. Let's see what is happening over here. R squared value exactly the same. Okay, the overall p value almost the same. Now is large sk is just the opposite. The coefficient was earlier negative, now it is positive. Okay, and the p value remains the same. Obviously this was expected. This is kind of a logical answer, right? So this is how we saw that we could perform label encoding and we could do the encoding of the data set. Okay, so this was just an example. We will be taking and I will be sharing more and more examples with you, which is going to have, let's say, real life examples of how we can do label encoding. and that you can give it a try. I'm also going to share a data set quite soon. I'm just going to download it now and I'm going to share that with you. It's for the prediction of sales. It's for prediction of an amount field, and there are 4 to 5 columns in that data. It's quite dummy, but not entirely. It's kind of a toy data set. And there we have a column which is actually a categorical variable. Okay, so you can try out these things that we have learned. We can take a logical pause, or we can take a logical end now, and then in the next session we can see how we can do the one hot encoding using two methods. So there is one method of doing one hot encoding, which is using pandas data frame, right? One method is completely manual. We may want to overlook the manual thing there, because it will require some lines of coding, which we usually avoid when we are doing the data analysis, because the more we code, the more we have to maintain it, right? So it should be as simple and as intuitive as possible, because this is like the data analysis is like the research that you are doing on top of the data, right? So it must be much intuitive, right? So we are going to use pandas. Pandas has a very, very interesting function called get underscore dummies that creates one hot encodings. Okay, it helps create. And then in that same library, sklearn pre-processing, we again have another library, which can be, or a method from that library, which can be used to do the one hot encoding, right? Let's make a stop here. I'm going to share the details with you very soon. I'll also share the materials of yesterday. I'll stop the sharing. Thank you so much for joining.
Thank you. Yeah. Good
Thank
night.
you.